Thanks a lot. Last session of the conference. I think it's time for a big hand for the organizers because it was a great event. Cool. So, observability, everybody's favorite buzzword nowadays, right? So that's what we all need to do. I've been introduced, so let's skip over that. My official title is Developer Advocate, and this is, by the way, the best way to test if the organizers can print UTF-8 correctly on your badges. This is the ultimate test because it's often like a square or something else that is broken. That is my test for conferences. I do a lot of conferences, so let's dive into the content here. Who is using logs? I guess that's pretty much everybody, right? It's sometimes called like the ancient pillar because this is what the generations before us have already been doing, is you have an occurrence of an event and you write it out. It's very simple. It's also very simple because it's kind of like on the component level. So if you have any distributed architecture, you just have like a log here, a log there. You don't really see the bigger picture, but you have like little bits and pieces, which makes it good to follow some events, but doesn't give you the full picture every time. That's why we need more things. For example, metrics are, the nice thing about metrics is they're the periodic measurement of something like how many requests did you have, what was the response time, what is the error rate. They're aggregatable, so you can get a very good overview of what your system is doing. Sometimes people call it the original observability pillar because it's like the thing that many people have started to see what is happening in their system and see what is going on. The downside of that is it gives you a very poor overview of why something is broken. It shows you something is broken, but it doesn't really tell you why. And for that, we've been adding traces or application performance monitoring sometimes, depending on which terminology you try to follow. I basically try to scratch APM, and nowadays, I think baseline on tracing or distributed tracing, it's the activity per request. So it's application scoped or request scoped. So independent of how many services you have in one request, you have one thing to trace that entire request throughout your entire system, so it gives you a much broader overview of what is happening. And nowadays, I think it's kind of like the cool pillar, like everybody is trying to do tracing, and OpenTelemetry, I think, has also helped out with that. So what is observability then? Many of you have probably seen this one. Is this observability? Nobody dares to raise their hand. Okay, you have been well trained. So depending on where you are, some people will say that this is observability, and others will be like, no, this is definitely not observability, and you're doing it all wrong. I can tend to agree that this is not observability, but it's still a helpful model. So the idea is that you have these three things, logs, metrics, and traces, and they each bring their values. Like you have events, and you have the request scope from tracing, and you have aggregatable metrics. And then you can combine them. So for example, you could combine tracing and logging. So for example, in tracing, which is always request scoped, you would have a unique ID for every request. And then you could keep that request ID in every log. So you have then scoped logs, and you could find all the logs for one specific request and tie them together. So if you have one error, you can find all the related log messages around it. And the same then goes to request scope metrics, where you could find that on a metric level. You could have aggregatable events where you try to roll up specific things from the logs, like, bless you, the logs you try to roll up into, like, I don't know, what is the error rate from these logs that we have extracted. And then you can kind of like combine all of these into request scoped metrics, into request scoped aggregatable events. And that is kind of like the goal. But this is still not observability. This is just collecting the underlying information. I really like this tweet where somebody was saying it's a bit like calling Formula One gasoline, motor oil, and tires. These are all necessary for Formula One. You will not have a Formula One race without these three, but they're also not why people are excited about the Formula One, right? And it's kind of like the same for observability. You need all these different types of data, and they're kind of the foundation, but they're still not the essence of observability. They're kind of like the foundation and you build on them, but they're not the thing. And then people are like, we can extend that. And this was, I think, came up last week or so. There was a blog post that found 6 pillars, and they called it Temple. So they have a very nice name for it as well. So they have traces, we know these, events. Events are like change events. It's like every time you deploy or every time you change your infrastructure, that's an event. Metrics, profiles as in profiling data, something that you potentially run explicitly to extract more information, also because it could be expensive. Continuous profiling is another thing that is getting more and more attention, is where you have like the call stack, that you look at that to figure out where, on a deeper level, where is data coming from, though it does collect a lot of data. Logs we know, and then they broke out exceptions here, which is like the old take on this is all the things that are going wrong, and you potentially want to aggregate which trace or which exceptions have been happening the most or most recently, and you want to aggregate those to figure out what are the unique errors that people might be running into our system. Sentry, for example, is probably the #1 tool for that. So you can add more data and you can give it more names. Sometimes it's also called melt, which would be metrics, events, logs, and traces. So you can come up with all kinds of fancy names, but that doesn't change the underlying thing, that it's collecting the data is important and the foundation, but that's still not observability. And yeah, this one had to be added here. Where are the traces? Where's the stack trace? Otherwise, it didn't happen. But that leads us down to that road where it's all about the tools, right? Like in Toy Story, where it's tools everywhere. Which kind of reminds me of this other thing. Since we are at DevOpsDays, hasn't the kind of the same thing happened to DevOps to some degree? So people are very big on like, these are these DevOps tools, and if you use all of these tools, you're DevOps, right? Yes? Yeah. So it is very convenient, and if you're a vendor of any of these tools, this is great. It still doesn't capture the essence of DevOps. It's like, these tools might all be necessary to do DevOps, but they're not the essence of DevOps. And where this is coming from, I assume everybody knows pets versus kettle. No? Some? So pets versus kettle is, I'm old enough to still remember pets. Pets was when you rented your virtual server, and you gave it a name, and then you kind of like grew it by hand, like you installed some packages, and was absolutely unique. It was a snowflake that you could never recreate. And that was a pet. And if it was sick, you had to take care of it because you couldn't recreate it because nobody could get it back to that state. Nowadays, we're more in that kettle state where it's like, it doesn't have a cute name, it has like some scheme of naming. It's not raised by hand, but it's created automatically. And if it's sick, it gets shot so it doesn't infect the rest of the herd. And that's kind of like the infrastructure that we're building. So we went from this static monolithic architecture where it had cute names and we did lots of stuff by hand to this elastic microservice architecture, which is a lot of buzzwords again. But it's a very different way of building applications. But of course, we need the tooling for that. So back in the days, you had that cloud maybe, but you had a load balancer and you had your beloved monolith, and then you had a database. And everybody could understand that. And everybody could also manage that with logs, because you would just tail that one log file of the monolith, and you would follow it, and everything was clear, right? Who likes this model? Maybe it's too simple to keep us all employed, right? So we had to find something better, and this is better for us to be employed, but also better for the vendors. So it often looks something like this, where you have a lot of services and a lot of databases, and everything calls everything else. And here you need a lot of tooling to actually A, deploy that, but also B, to monitor or observe that. So this is kind of like the ecosystem where we're coming from. And then we turned all of this into tools and jobs and departments. And this also totally makes sense, because I was looking at the salary data. If you call yourself a system engineer in the US, your average salary is 100K approximately. If you call yourself a DevOps engineer, it's suddenly 125K. So just renaming yourself, you can increase your salary by 25%. which is a great trick, right? Which brought people to this idea, which said, like, we should do DevOps, right? And nowadays, we're kind of switching to we should do observability because probably we can get paid more. So that's why everybody's chasing observability. So what is observability? Because I've been talking a lot of what observability is not, but what is observability or what is it trying to do? And there's the official definition from control theory. It's observable if the behavior of the entire system can be determined by only looking at its inputs and outputs. But that's not telling us anything, right? That's a very nice definition, but it's not very practical. What I think is more helpful is the known knowns and unknowns, which you have potentially seen before. So there are the known knowns, the things we are aware of and understand. These are the dashboards that you have and build. It's like scar tissue, like you have been hurt somewhere, and then you put it on a dashboard to not be hurt there again, or figure that out quickly. They are the unknown knowns, things we are not aware of but do understand. That is like something that we are collecting and we don't really know how it might behave. This is, for example, where you have some anomaly detection. Some system is behaving differently than it was in the past. We didn't explicitly create an alert on it because we didn't really understand it, but we're genuinely aware that there is this thing and we should be looking into that potentially. Then things we are aware of but do not understand. That is, well, we need to kind of like slice and dice our data differently. It's more like if you have logs, metrics, and traces, for example, but you don't want to have them as a silo, but you want to go from one to the other. It's more like picking up a signal here and then trying to understand more by going from one piece of information to another. It's really just trying to understand what you have here because you have the data, but you don't really understand why. And then the things we are not aware of and do not understand, that's maybe kind of where observability is. It's more to collect rich events. So you collect a lot of data, and then you hopefully be able to figure out something that has happened without changing the system. Because complex systems have this pesky thing that every time you try to redeploy some code to add more logging, for example, the bad behavior disappears. And you cannot find out why anymore. Only then to reappear in the middle of the night again, and then nobody's around to actually look at it. So it's very tricky to figure that out. So observability is more about like you want to have richer events where you can correlate the data and where you can jump into it to figure out what is going on as needed without redeploying. And that was kind of coming from the definition from the previous slide. You can determine it by looking at these inputs and outputs, so you don't have to change anything in the system. You can observe it by just what you have already. And that leads me to survivorship bias, which is also a common thing, which comes from World War II. Like the British were looking at the planes that were coming back after having a flight sortie, and they were basically counting where are the bullet holes in the plane. And their basic assumption was like, well, we'll add some reinforcement where the bullet holes are, so we make our planes better, right? Who would do it like that? Okay, no, very few dare to raise their hand. But then, when you think about it, these are the planes that are actually coming back. So these are the good planes. The planes that are being hit here or here, they don't come back. So probably you should reinforce there. And that's a bit like what we often do with monitoring dashboards, where all the bullet holes from the past that we have understood, we monitor very closely and try to reinforce there. But we often forget about the things that don't come back or that we don't see. And that's the problem of the survivorship bias, that we're very biased on like what happened in the past, and then you try to reinforce there. But you're not preparing for the future, the next incident. And that's where observability is coming in to make us change that and be prepared for that future. So what you want to do is you want to have state and answers. What is the status of my system? What is not working, but especially why is it not working? Just to figure those out, that's kind of like the goal of what you want to reach. There is this nice comparison saying that monitoring is telling you that you don't have any money left on your bank account, and observability would be telling you you don't have any money left because you spend it all on chocolate and sweets or computer parts or whatever else you spend your money on. So that's kind of like the difference, that the monitoring is very much like that is what's going on, but that's not really what you want to know. You want to have that step behind to see where this is going. You can also make some fancy graphics. So the yellow part, it might be a bit hard to read, is traditional monitoring systems, and this is observability. In both, some sample data comes in, and then here, you aggregate it, you have an expiration function, and then you have a metrics dashboard that says like 99% of our requests are okay. Then you have a threshold and say like if it's below 99% or not below 99.5%, then alert somebody. That's a very traditional way. And in the observability way, it's much more about collecting that raw data. You still have an expiration function, but you have the events, and then you can look into that data ad hoc and kind of like figure out more what is happening here and why. It's not just, oh, something is broken and shouting, but it's more like it's broken, but I can also figure out what is different or why is something different. And then you can match on specific patterns here then to trigger an alert. So it's not just a number, but it's really more about understanding, bless you, the system. So where is your innovation? Some people say that we have reached the optimal data types, like logs, metrics, and traces, and maybe you can give them more fancy names, are all we need. And I think that's probably true, because we have had logs, metrics, and traces to some degree for ages. Like the logs, when a ship came to port, are hundreds of years old. So it's a system that is well established and works well for humans. Where the innovation is more on top. It's not so much about collecting the data, and I think OpenTelemetry is doing, for example, a great job of making it easy to collect all the different signals. The innovation is more like, how can you visualize the data better? How can you correlate from your metrics, like what are the relevant logs, why something is broken? What are the requests that are triggering the high latency or the failure rate? Show me why something is happening in a specific way. Is it a specific group of users? Is it a system that is affected? It's really that diving into the data and making more of the data. I don't think that data types themselves really change what we are doing. It's more about using that data and having a higher level system of figuring out what's happening there. Which then creates the problem that many vendors come in and say like, oh yeah, we're doing that. We have always been doing that. You can still put your crappy software inside a container and it's cloud native. You can still take your old monitoring system, call it observability, and it's all great. Maybe not quite. So what you want to have is you want to instrument your systems without shipping new code. Like I said, whenever you redeploy your application, oftentimes the problem goes away magically. Maybe that's also a solution, but it doesn't help you to understand why something was broken in the first place. And you need to understand your system also in the good way. There's this nice comparison. If you only try to learn how your system behaves from the broken system, it might not work that well. It's like trying to understand marriage just by looking at divorces, which might not give you the best impression of like how marriage or your system should actually work. So you need to understand what is the baseline, what is normal, and how does my system behave normally, and not just look at the dashboard once it's broken, because then you don't really know what is normal, what is not normal, what should be here and what shouldn't be here. So it's more about having this general overview of your system. So we collect all the things, right? Everything that is flying around. But not all signals are equal. Overload of PagerDuty overload is, I think, a common topic. You don't want to be paged for everything. For example, what might be important is that people are able to log into your system, that you can have a successful transaction, that your search is performant, that you can put something in a shopping cart and when you buy it, you actually get it out. If some API that no system is using right now is up, nobody cares. If your error rate is up, but it's kind of like you have a retry mechanism and it's covered in the background, nobody cares. If your query latency is double as it was before, but it's still acceptable for the user, those are not things that you need to wake up a human in the middle of the night. So while you should collect a lot of this information, not all signals are equal. You cannot just say like, oh, this is the threshold, this is normal, and for everything I will wake up a human in the middle of the night if it's different. But you need to be smarter to understand what is actually important. Which leads us to service levels, which I think is well understood, and I don't have to go into these. My favorite take is, though, service level agreements. If your uptime is not what you promise, you owe me money, or at least an excuse or something like that internally, which I think is the best explanation of how the service levels are generally working. So, one other thing, maybe you don't need the uptime that everybody says you do. How good is the uptime of GitHub? Pretty bad oftentimes. Is everybody still using GitHub? Yes. So maybe you don't need to stress out too much over uptime, because probably your service is not more important than GitHub. Because if GitHub is down for us, not much happens anymore. But GitHub seems to be fine. This does not apply if you do pacemakers or other medical devices, of course. No, I'm just saying that because there were these cases when Amazon, one availability zone in Amazon was down, and then some maker of pacemakers that was monitoring the pacemaker said, like, we had deployed our application in a single availability zone, and it's down now. And that's not a good situation to be in. So there are cases where this is not acceptable, but for our average IT system, probably we can be a bit more relaxed. Who likes the term AI ops? Or ML ops, or MLOps, or I don't even know how to pronounce it. So I think that AI ops, because AI is very aspirational at best, should always be called actionable insight, and that would make a lot more sense. That is what we want to do in observability. We want to figure out what is actionable, and we want to see that and find that, and then we want to be able to do that. It's not that there is the magic AI that will fix our systems without us knowing what is going on. I don't think that's a very realistic expectation. It's maybe not even desirable, because then we would all lose our job. But it's not realistic, so it won't happen that soon. The other thing is, you cannot buy observability. Somebody will try to sell you observability, but you cannot buy it. So what I mean with that, taking a log. So this is, you have a login in a system, and you have a timestamp, you have a log level, and you have a human-readable message. Philipp failed to log in with password, and I've masked the password. And this is nice, but this is mostly useful for a human, right? Because they understand what is going on. If you now have a lot of these messages, will you be able to tell what is going on in your system? Not really. So what you ideally do is you turn your old school logs into events. So we still have the message for humans, but we then extract some pieces of information that are helpful. So for example, I would have an event category which says, this was a login failure, just so that I know, like, what is the number of login failures in my system right now, and is it spiking or not? I could tell, is only one user affected, or are more users affected? So did I just forget my password and I failed to log in because of that? Or is like all my users are suddenly failing to log in, because then it might be something more in my system? From which IP address is that coming from? Is somebody trying to brute force the logins in my system? On which endpoint is it? All of these let you graph out what is going on in your system, and you can then get much better information to figure out what is going on. Is it a general problem? Is it the problem of one user? Is it the problem of one host? Once you extract all of these values, you can slice and dice your data and get these insights. If you just have the human-readable line, then you will have a very hard time doing that. And of course, the value is always there for the business. While we in IT oftentimes like to do things because we enjoy them, the actual value and why we normally get paid is to provide value for the business, so that should be the goal. Which also means, if you collect all of the data, but nobody's ever looking at it, you're probably not adding a lot of value there. How many dashboards do you have in your organization? A lot, right? I was recently talking to people, and they said, like, we have 500 dashboards in our organization, and nobody's ever looking at them. And then it's really like, why do you have them? Or there is this old joke, can you hire enough interns to stare at all the dashboards to figure out when something goes wrong? Which is also not a very helpful approach. So that business value, like, observability is great. You can collect all of that information, but if you don't use the information correctly, are you gaining much from that? So to wrap up, since we all want to go to lunch, monitoring is, you know if the system is not working. the take of observability then is to know why it is not working and hopefully how to fix it. So you don't have to just run around crazily in the middle of the night. And regardless if it's 3 pillars or 4 pillars or 6, and I'm sure next week somebody will come up with 7 pillars. That is just the data that you collect, and that is an important foundation, but it's still only the data. That is not what observability is about. It's not the value that you extract from it. It's important to get the data and be able to work with that. But neither the number of pillars nor just having the data alone is like the end goal of what we want to do here. And again, repeat after me. Neither DevOps nor observability you can buy, though I can totally sell it to you. We can talk about that later. Thanks a lot.
Okay, amazing talk. I think you can all agree that even though it was last-minute surprise, very nice. Thanks, Philipp. Any questions for Philipp?
Should I take a picture with you again while you think?
Yeah, fair.
You want to join? Like,
why not?
Some organizers.
We should have them all, but yeah, sorry.
Oh no, come up on stage with me.
Oh, on the stage?
Yeah, come on.
Really? Okay.
You all fit in? Cool. I'll post it afterwards.
There you go.
Any questions? Everything was clear?
We have one there, Yves. Yeah, thank you.
Well, you spoke about machine learning, AI, maybe not the AI, but what about using machine learning and new techniques to discover patterns and to help to improve observability by some observability in effects and even cross patterns between, let's say, different companies, different places, different installations, different softwares, in order to improve the rate of success?
Yes. I think that machine learning or any automated detection has a lot of value. I'm also required to say that because we sell those solutions. But no, I think machine learning has its value, and you can detect a pattern, especially if you have like a regular pattern each day. And then machines can do a very good job at detecting that. It just relies on that there is a regular pattern, and that not every deploy will kind of throw off your detection. So there is value to that, and you, like I said, you shouldn't stare at the dashboards all day long. Like machines can do a good job of figuring out like, oh, this was like this the last week, and it probably should be the same. So those are totally helpful. I just think, or my problem is that with ML ops and AI ops, we totally oversell that. It's like, you don't need a human anymore. Like the machine will know all of this, which is totally, of course, not the case, but we all know this. It is definitely helpful tooling, and it should be used because you cannot stare at everything at all the times, and we're not very good at that. So it totally has its place. I'm just a bit cautious because it tends to be so oversold, and I think that promise has not been fulfilled.
Okay, thank you.
Who is using ML or AI in their observability or monitoring tools? Okay, that's a sobering number. Last chance for questions? Or everybody hungry? I'm happy to discuss more over lunch. By the way, if you want to have a few stickers, I brought a few stickers. Grab them here. Otherwise, thanks a lot.
Yeah, thank you, Philipp.